Okay, so here we go. Yesterday we learned, okay, to state a measurement with its uncertainty. And so from that we can this is basically telling us that the measurement could be larger or smaller than what it appears at first glance, right? That's what this is telling us. So we practice that to a certain degree. Let's go over here, and it wants us to state the measurement plus or minus uncertainty. The measurement is 22.5, right? So you would start with that. And we are in Celsius there, it doesn't tell us, but we're in Celsius. Plus or minus, the uncertainty goes right here. What do you need before you get the uncertainty? You need your precision. Precision is 0.1, right? And what's the uncertainty? 0.05. That's what goes there. Okay, so you would go 0.05 degrees Celsius. This is what the province would want you to state. Sure, you could show the work, but that's what they would want you to state. Yes? How did I know that precision is 0.1? Because that number that you're reading, the device that is measuring that temperature, right? You look at that 1 decimal place, and that's the smallest amount the temperature can go up or down by, where it can actually register it. And then I got my uncertainty, and then I got that. Sometimes, Christian, you're asking, so I'm kind of giving you a different scenario. Sometimes they will tell you what the precision is on the side. You got to go off of that, whatever they state, to come up with the uncertainty. If they don't tell you, you have to just read the number and get it off of there. Okay? What's the maximum and minimum based on this? Right? The max is 22.5 plus 0.05, and the lowest is 22.5 minus 0.05. So I'm adding and I'm subtracting. So the max is 22.55. And the minimum is 22.45 degrees Celsius. Okay? So that's one of those where there was a number. Okay, this device had a number on it. So that's where we based it off of. What about this one? If you're given this thermometer right here, it's in degrees Fahrenheit. I'm going to just put that, write down degrees Fahrenheit on top of it somewhere. How would you state this one in this format? Page 20. The other one is measurement plus or minus uncertainty. What would you say the measurement is right here? It is actually right on that line. 71, 72. You got to do the precision first here, okay? We want to find out what does each marking, what does that go up by? So let's do that. Precision is, I'm going to call this my low, and that's the high. So it's 80 minus 70 divided by how many gaps are there between numbers? 1, 2, 3, 4, 5. You're following that, right? It's 5 gaps in between. So that'll be 10 over 5. So that's 2 degrees Fahrenheit. So every marking represents an increase or a decrease of 2 degrees Fahrenheit. Does that make sense? Why I did that? Christian, you're not so sure. Ask. It's 10. If these markings hadn't been there, if the only markings had been right where the numbers are, then it's 10. But because there are markings in between, you need to count them as it's one little step, right? So we use these numbers to subtract, and then we divide it by how many little gaps there are between the numbers. So you have to be extra careful there. So the precision is 2, therefore the uncertainty is 1, right? It's just 1 degree Fahrenheit. It's just half of that. So let's go back to what the measurement is. What would it be if it's not right on 70? If it's 1 over, it's 72. 72 degrees Fahrenheit. Plus or minus, we know that the uncertainty is 1 degree Fahrenheit. There you go. What's the max and the min? I think we don't need to show the work here, right? Max is 72 plus 1. And the minimum, it could possibly be in that room, is 71 degrees Fahrenheit. So these are things that, need to be comfortable with. What about this one here on the side? What's the actual temperature? Let's go Fahrenheit. What's the actual temperature? Fahrenheit, what would you say? 68 or 69, right? In between there. So you pick. I'm going to go 68 because this crowd can handle the other number. Oh, yeah. Oh, I made a mistake. Mr. Dirksen, you are way off. That's right. If this is 60 and that's 80, then this would be 70, right? We can just conclude that. How many gaps? How much is each one worth? You go high and low again. High, low. Let's go precision. We go 80. You could go 80 minus 60 if you had wanted to, but I'm going to go 80 minus 70. And then I'm going to count 1, 2, 3, 4, 5. So the precision is 10 over 5, which is 2 degrees Fahrenheit. Which means every time I go up these markings, I go up by 2. So let's try this again. 72, 74, 76, 78. Yes, you are correct. Plus or minus. What's the uncertainty here? If precision is 1, uncertainty is just 2, sorry. Then uncertainty is 1 degree Fahrenheit. Okay. We won't do Celsius. We'll just stick to Fahrenheit here. The key probably has Celsius. What's the maximum here? 78 plus 1. The minimum is 78 minus 1. Okay. So we basically just add to get the max. We subtract to get the min. All right. I want you to try this one here. This page, measurement plus or minus uncertainty for every single one of them. Okay, I can give you a name. Okay, I know I helped a bunch of you with this, but I didn't help everyone. Okay, so follow along. When it comes to these ones, I know this is very counterintuitive, but you have to see which one is this bar, which marking is it closest to. That's how you read this. Okay? What is this? If this is 10 and that's 20, you can probably guess that this is 15, right? But if you've missed it completely, you just go high minus low, divided by 2, you still get that. So it's 5 centimeters. Uncertainty is plus or minus 2.5 centimeters. So the measurement, if they ask you to state it like this, the measurement right now would be 15 centimeters. Please make sure you add units everywhere. Okay, just make sure you add units. Plus or minus 2.5. That's how you would do this particular one. And then I know some of you, you'd actually, in the real world, like if I asked you, hey, how long is this piece, 16 or 17, probably would have made more sense. Like to guess that that's 16. But imagine that this thing is a digital thing that spits out a number, and it can only give you 15, 20, 25, or something else. It cannot do anything in between. Okay? What's the minimum? Minimum is 15 minus 2.5. That's 12.5 centimeters. Max is 15 plus 2.5. That's 17.5. Okay. I want you to understand this part right here that we're doing. I want you to imagine that this number, the 15, is just showing up on a screen, right? Like, how long is this? It's 15 plus or minus 2.5. And now we're wondering, well, based on this, like, it could be off, right? So then we're saying the smallest this bar can possibly measure based on this information is 12.5. And the longest this piece could possibly be, based on this information, is 17.5. So that's why the plus or minus is always there. Okay, so we're saying the piece could be anywhere between here and here. We don't know. And obviously you can see it right now, but if I were to take this away and I had just given you that measurement, then this is what we're going to assume, right? That if we were to add these two together, we get our max, and if we subtract, we get our min, the lowest possible, okay? Next, the beaker. I hope, like if you, okay, I'm just going to make sure you understand. This one always works. So if you pick any two numbers, high and low, okay, you go 40 minus 20. 40 minus 20, and then divide it by 2. You count how many gaps there are between the high and the low. That's 20 over 2. That's 10. Okay? So the precision is 10, which means it goes up by 10. So this should be 30, 40, 50, 60, 70, right? That every marking, as you go up, a marking at a time, you're going to go up by 10. So this, the liquid is the closest to 50. So it's 50 plus or minus, what's half of 10 is 5, right? So we're going to go plus or minus 5. It should have been milliliters. I didn't add the units, that's my bad. And so the maximum is 55 mLs, and the minimum is 45 mLs. Okay, keep going. This one, I don't want you to be, I don't want you to skip fractions, guys. It's okay. Some of you ask me, how do you find the precision, Mr. Dirksen? Like, this is confusing. Do you think the high minus low, guys, what are you doing? You think the high minus low is going to work on this one? Yes, it will. Watch. I'm going to pick this as my high and this as my low. What is 3/4 as a decimal? I hope you know that one. 0.75. Half as a decimal, 0.5. And so to get the precision, you go high minus low. And how many gaps are there between those two numbers? 1, 2, 3, 4. What's 0.75 minus 0.5? 0.25, correct? Divide that by 4. What do you get? What, right? you get that, 0.0625. That is technically your precision. Anybody figured out what that is as a fraction? Did anybody count how many gaps there are from the bottom to the top? One, were you gonna say that, 1/16? Let me see if, yeah, it does. If I press this button on my calculator, it goes back between decimal and fraction, right? I don't know if you have that button. Mine looks like a fraction, ABC. So it is 1/16 or this, or 1/16 of a liter. Either one would have been fine, okay? Okay, so what's the uncertainty therefore? It's half of this. So I'm going to turn this into decimal again. I'm going to go divide it by 2. The uncertainty is plus or minus 0.03125 of a liter. And now we can set the measurement. What is the measurement? How much liquid is in there? This isn't hard, right? This one is right on the line. You can go 1/4 of a liter plus or minus 0.03125 of a liter. Is this a crazy example? Yes. I think this one is a little out there. I don't think the province has ever done this ugly of an example, but you should still be able to do it, right? Like, you have a calculator, turn your fractions into decimals, just work with it, okay? What is this as a fraction? I cleared my calculator. It's 1/32. You multiply this by 2 to get that, okay? All right. I think we're good for now. I might come back to this. So I'm going to stop this there.